I am Dharmendra sir from Divine Public School, your science teacher. We are going to start with our same topic, light, reflection and refraction. Now yesterday I taught you how does an images form in a plane mirror. But before starting a concave mirror, I need to brief you a little how does a light behave when it passes at certain points. Once you get this thing, we'll again get back to a concave mirror and we are going to discuss 6 cases today. One I already started, still I'll refresh it again, and then that is how we are going to see the 6 cases. The same we will see for the convex mirror tomorrow. So let us start. First, I am going to tell you how does a light behave when it passes at certain point. Okay, this is going to be true for both the mirrors, concave mirror and a convex mirror. So let me show you. See, for a concave mirror, this is your principal axis. Okay, now let's say this is your F and this is your C. Now, the first case tells you if a light is parallel to principal axis, right, after reflection is always passes from principal focus. So after reflection, it always, if a light is parallel to principal axis, so whether you draw it here, anywhere, it should, the first condition is what? A light should parallel to principal axis. That is an incident ray. Okay. Now, if a light is parallel to principal axis, after reflection, it always passes from principal focus only. It is a rule and it is always there, whether it is a concave mirror or is a convex mirror. I'll show you for both. So here is what I said, after reflection it always passes. This is the first rule. I'm going to teach you 4 rules of a light. The first rule, if a light is parallel to principal axis, after reflection it passes from principal focus only. Similarly, let's see for the convex mirror. Okay, so this is your principal axis. This is your, now this is your F and this is your C. Here the curve goes on the other side. Don't remember this thing. Now the ray is parallel to principal axis. So let me draw a ray parallel to principal axis. Now the reflecting surface on the left side. So I'm definitely going to draw the ray here only. Now as what you know, this is a divergent mirror. So this is a divergent, means after reflection, the light goes like this. So incident ray, this is reflected ray. But if you try to extend this light, it always passes from F only. So that is how. Here the line is, the F is on the left side, so it is anyways give you a real image, and in the convex mirror it is going to give you a virtual, because in real it is going to be on the other side, but when you extend it, it passes from F only. So the first rule what we learn, when a line is parallel, when an incident ray is parallel to principal axis. So that's the first point. If a line is parallel to principal axis, after reflection, it always passes from after reflection, it always passes from principal focus. It is always true. This rule will not change, right? So, but the condition is it should be parallel to principal axis. This is the first rule. Now, what is the second rule? This is your concave mirror. This is your principal axis. Now, the second point is if the reverse way, if your line passes from principal focus, then after reflection it will become, so let me show you. If a light is passing, so the incident ray is passing from principal focus, so it will touch here, and after reflection, where does it go? It will become parallel. So understand this thing. It will become parallel. So here the light is, this is incident ray and this is the reflected ray. So what is the second rule? When a light is passing from principal focus, right? When a light is passing from principal focus, what is the thing? After reflection, it always passes from, after reflection is always pass, it will become parallel to principal axis. So it is exactly the reverse way of what we saw in the previous case. What we saw in the previous case, that when a light is passing, when a light is parallel to principal axis, after reflection it passes from principal focus. This is reverse. If a light is passing from principal focus, after reflection it will become parallel. The same is the case. Let me show you in textbook quickly. So the same is the case. See, the first case we saw. Can you see here? So when it is passing from F. See, the first case is this. When it is parallel, after reflection it passes from F. Similarly, for a convex mirror, it will go up, right? But when you extend, it passes from F only. Here is the second case. When the ray is passing from principal focus, for a concave mirror, after reflection it will become parallel. In the second case, if you see, when this is the incident ray. So this is actually the incident ray. After reflection, it will become parallel. Okay. So how does it work for a convex mirror? As what I said, you have to draw your principal axis. Okay, and this is your incident ray. So this is your incident ray. Now this is your incident ray here. Okay. Now if you see, it will meet here. Now this is your F. So when you extend it, it passes from F. But after reflection, it will become parallel. Okay, so this is your incident ray. After reflection, it will become parallel. So this is what happened for the same rule. So we learn two rules, right? Let's see the third one. Third one is what? Pass if you pass an incident ray from the center of curvature, okay, so this is again your principal axis, this is your C, this is your F, and this is your C. Now what they are trying to say is, if you pass an incident ray from center of curvature, so let me draw a center of curvature here. So if you pass an incident ray from center of curvature, the thing is, this is your incident ray. So after reflection, it will pass from center of curvature only. So this is the thing. After reflection, it is going to go from the same point. Okay. So third case, what did third case tell you? That if an incident ray passes from center of curvature, after reflection, it will pass again from the center of curvature only. So let me draw a convex mirror and I'll show you. So this is your principal axis. Okay, now suppose this is your incident ray. This is your incident ray. And here let's say this is your F and this is your C. So they said after reflection, it passes from the same point only, but when you extend them, right? When you extend it, it is passing from C only. So this is the same case. So in the third case, what did I tell you? That when a light passes or when the incident ray passes from center of curvature, after reflection, it passes from center of curvature only. Right? Let's see in our textbook what they say. See. So the incident ray after reflection, it passes from C only, and the same is for convex mirror. Right? And this is the last case. If you see in our last case, right, if an incident ray is incident at pole, okay, so if an incident ray is incident at pole, so this is your mirror. Let's say this is your principal axis. If an incident ray is incident at pole, okay, so this is at pole. So if an incident ray is incident at pole, so this is your incident ray. So what they say is, after reflection, this is the reflected ray. So this is your angle of incidence and this is your angle of reflection. So that's what they said. The angle of incidence is equal to angle of reflection if the incident ray is incident at pole. So that is what they are teaching you here. What? An incident ray is if an incident ray is incident at pole, then the angle of incidence is always equal to the angle of reflection. See here. So the incident ray, if it incident at pole, the angle of incidence is always equal to the angle of reflection. The same is the case for a convex mirror. Okay. So in order it get too long, I'm going to sum it up here. Again, I'm going to show you the same, right, in the next lecture.